Jaden, Landon, Genevieve, Grayson, and David. And Landon with a Y. Cross out yours, you don't want it? Landon Smalley. Okay, I don't know if it's too late. I'm going to go to the office right now.
All right, good morning, e-learners. You got to see that.
Yeah.
All right, get out your homework, guys. Christian, you're going to be a day behind. Yeah, I'd be okay with that.
So what are we gonna do?
Well, you took your test, yes? Yeah. So you missed our introductory lesson. Yeah. It's okay. It's fine. That's people's drooling inside their mask because it's.
Oh wait, is it okay? No. Is it okay if I bring 50-pound weights and put it in my backpack for Jamie to carry?
Where's Jaden? You got his bag?
It's right here.
What?
He's been carrying it though. I
All right.
put like everything.
Good morning, Cadence.
I mean, that's a smart idea.
All right, Cadence, if you have any questions during the class, you can unmute and ask any question at any time.
Wait, are we doing this live?
Yes, we've been doing it live since. Okay.
What's up, Pigs?
Okay, let's get going here. All right, questions on the homework. Questions on the homework. Genevieve, go. Just leave it in there. Yes. Let's look at 18 and 20. Number 18 and 20. From the book, number 18 says the following. It says 3 to the second times 3 to the fifth. 3 to the second times 3 to the fifth. Now, the rule of exponents, Christy, do you remember? Are we allowed to multiply the two numbers together?
No.
We are, as long as the big number is the same. In other words, the base are the same. Christian, are the bases the same? So Christian, when the bases are the same, the rule for exponents are you rewrite the base, you don't multiply 3 times 3, and you do what with the exponents? So therefore the answer is 3 to the 7th power. Very good. So there's 18. What was your other one? 20? Same way, same thing. It says write as a single power of the given base. But just so you know, if the bases are not the same, you cannot do that rule. You have to expand everything out and then multiply. It's ugly. Jaden. So 12 says the following. Which one is greater?
Right, but I didn't know like the answer was 8.
What is 5 to the 2nd power?
Right, but I didn't know if it was similar to
What's 5 to the 2nd power?
5 to the 2nd power, 25,
What's 2 to the 5th?
32.
So 32 is bigger than 25.
Right.
Use whatever inequality symbol you want. Or just it says which is greater. So I guess you could just say 2 to the 5th and be done with it, right? Okay? All right, let's grade this. Here we go. Where's your homework? If this had been the first year that I taught you, I would cut you some slack. All right. We've been doing the same thing for over a year. Way over a year now. All right. Number 2 is 625. 625. Number 4 is 216. Number 6 is what? 34. Very good. Number 8 is 25. And number 10 is 17. Number 12, I just said, well, the bigger number is 2 to the 5th. Or 32. You could say that. 14 is 10 to the 3rd. And 16 is 10 plus 2 is bigger than anything to the 0 power is 1 except for 0 to the 0 is undefined. Okay. All right. Number 18 is 3 to the 7th. Number 20 is 5 to the 11th. Number 22 is 4, big fat 4. Number 24, bigger number, 729. And number 26, anything to the 0 power is 1, easy one. 28 is 3. 30 is 98, 98. 32 is big number, 9,261. And the last one is even bigger number, 1,679,616. Good Lord. Yes, Genevieve.
What was number 16 and 14?
16 was 10 plus 2, and 14 was 10 to the third, 10 to the 3 power. Yes.
34, I put 58.
Okay, I'll accept that. All right, who's got the calculators with them? Pull them out. Pull out your calculators. Pull out your calculators. I meant to do this last week. Just have a calculator. All right, Jace, hand these out. If I get a calculator, if I give you a calculator, better get it back. Okay, now we're going to do this quickly. We got to talk about how to do exponents with a calculator. Now, you were required to have a scientific calculator. Look at me. This is called a scientific calculator because, well, it says scientific now. What makes a scientific calculator is got lots of buttons on it, right? There are other calculators that also have lots of buttons called a graphing calculator. A graphing calculator, well, one of the things it does is it graphs. Next year, look at me. This is the calculator or type of calculator, right? One of these two, right? You need to have a graphing calculator. For this year, if you want to use a graphing calculator, I don't care. But I will say this, for the state assessment you have to take, they give you a scientific calculator and expect you to know how to use it. You need one? Jace? He's working on it.
I need one.
All right. So let's talk about calculators. Now, every calculator is unique, but scientific calculators to do exponents have a special key. You're going to need to find it. If you have a calculator, the TI-30, it's on the right side. We call it the caret key. It looks like a mountain. It is an upside down greater than symbol, or I'm sorry, 9 degrees to the left, greater than symbol. This is called the caret key. Somewhere on your calculator, you will find the caret key. If you have one of those ones that we just gave you, where my index finger is where it's at. This is how you do exponents. So, for instance, if we want to do 8 to the 3rd power, we type in 8, caret key, 3 equals or enter. You found yours? No. Well, look, use your eyeball. That's caret key right there. So, everybody do 8 to the 3rd. You find it, Avery? Yep. You find it? Did everybody get 512? All right. What do we say that anything to the 0 power is? Type in any number you want and put it to the 0 power and see what you get. What did you get? 1. Now type in 0 to the 0 power and tell me what you get.
It said error.
You just blew your calculator up, right? Right. So if you do a mistake, you will certainly get that. Okay. So that is how you use the caret key and do exponents on a graphing or a scientific calculator. Okay. Can you remember that?
Yeah.
All right. So once again, you can always. Now we're moving on today. We're not doing exponents anymore for a while, but that's how you use it. Okay. You can use it, leave the calculator to your side. I should have done that on Friday, but we ran out of time. I did want to show you that before we did our homework. All right. Your homework tonight. That was a horrible erase job. Your homework tonight Nothing going on this week, just classes, 3-day weekend, chapter test. I do not give a quiz for chapter 2. It's just kind of a short chapter, and it just didn't seem like, hey, let me teach you 4 things and give you a quiz in between. So there's your homework for tonight. Cadence, just so you know, I will also post this class, or the recording of it, online, but it won't be until later tonight. So if you're wanting to review or something like that, you didn't take notes, you can always. All of you in this class right now have been enrolled into this class online. So if you, by chance, wanted to rewatch the video, you could, but I will not post the link to it until I get home and actually do the work. So I think I can get it done by, 8 o'clock every night. I'm not sure how that will help you, right? But it certainly would help you if you were, sick for a couple of days, you could at least. Also, not all the teachers, but I'm going to do all my classes live like I'm doing right now. I'm also going to record it. So if you are sick, Jackson, I sent him the link, but apparently he didn't show up. Could show up. You can miss absolutely not. I mean, if you're really truly sick, don't feel you got to show up to class type thing. But if it's, we live in the COVID world right now, so if you're like, well, I had a fever, but I'm feeling okay, but I couldn't go to school. Show up for class. Don't fall behind. Okay. I apologize for this class. I should just say, do your homework, right? You know how to do this. But every year, I get kids that come into 8th grade that literally can't do decimals. And by decimals, I mean they can't read the decimals. They can't do simple things with decimals. Listen carefully. I'm not teaching you how to multiply, divide, right, add, or subtract. We will do that this year, add, subtract, multiply, and divide with decimals. But I'm not going to have a formal class on it. All right? I will show you some tips as we do it and just reminders. If this is one of your weaknesses, I forgot how to add and subtract with decimals, and you need to come and see me for tutoring. This section is called the decimal system, and we will talk probably in more detail than we need to for an 8th grader about the decimal system. Yes?
Are you going to send it?
Yeah, why don't you come around and do this. Pass out. All right. Sorry, I didn't give you a sheet, did I? It's coming around. So, 3 objectives today. We'll talk about it when we get to them. So this is the thing that really, I don't want to say bothers is the right word, but I find it strange that you can get to 8th grade and you can't read a decimal number. So we're going to make sure that that stops right now, and we lock this into your brain so you don't go into high school and you can't read a decimal number to your teacher. So if you don't already know this, our numbers are based upon 10 numbers. Who knows what 10 numbers our numbers are based upon? What 10 numbers do we use? Name them.
1, 2, 3, 4, 5, 6,
Keep talking.
7, 8, 9,
You gave me 9.
10,
10 is not 10.
11, 0.
0 through 9 are our 10 numbers. Anybody know why we've, as human race, have said that we want to use 10 numbers and not 16? One civilization based their numbers upon 16. One civilization based their numbers upon 64. All of them have eventually said, you know what, we're going to go to 10. Who knows why we like to use 10 numbers? Yeah, right? We have 10 fingers. Count them.
1, 2, 3, 4, 5, 6, 7, 8, 0. Wait, no. 1, 2,
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
2, 3, 4, 5, 6, 7, 8, 9, 10, 11.
There are humans that have 12 fingers. There's one of them. However, it's got. I should know this name, but I don't. But 99.9% of all human beings have 10 fingers. So that is why we believe we are very comfortable with what's called the base 10 system. Genetic mutations. All right, up here, please. So we like to have our numbers on the base 10 system. Now this has some implications, right? The implication is this, and now this is not an 8th grade thing. This is, this is 2nd and 3rd grade when you were introduced to this concept of place values. As we go from right to left, as we move from this number to the next number, what is really happening? Mathematically, what is really happening? As we go from right to left, what is happening?
Increasing.
Clearly, but increasing by what?
7.
Can't be 7.
10.
It's increasing by, well, you got to be careful when you say increasing by 10. 80 plus 10 is 90. I didn't move over. How do you move from right to left? Mathematically. How do you go from 7 to 77? How do you go from 77 to 777? Right?
Adding a place.
How do I go from this place to that place?
Adding a place value.
Agreed. Mathematically, though, how do I do that?
Adding 10.
I'm not adding 10. You're saying if I had 700, if you add 10, you go to the next place?
Yes.
Absolutely not.
Yes.
0, you're asking about 0?
Where's Gabby? Help me out here, please. How do I go from one column to the next column from right to left? Well, how do I mathematically move from one column to the next column?
Yeah, the decimal.
You move.
How? Yes, agreed. But how mathematically? They're saying all I do is add 10. And I said, well, wait a minute. 710 plus 10 is 720. I didn't move to the thousands place. How do we move? We multiply by 10. You don't remember ever learning this? To go from this number to the next number, right? From one place value to the next place value, we're actually multiplying by 10. This wasn't ingrained into your brain.
I'm tired.
It should have been. If we move, listen please, listen. If we move from right to left, every single column of numbers is 10 times greater than the previous one. To go from the thousands to the 10,000s, you multiply by 10. To go from the 10,000s to the 100,000s, you multiply by 10. Each time you're moving over one place to the left, you're multiplying by 10. So what's the opposite of that?
Writing by 10.
So if we move from
Right to left.
we move from right to left, then if we go in that direction, then we're going to divide by 10. This is also what allows us to move decimal places, which is what today's class is about. When we move a decimal place, when we move from right to left, right, as opposed to left to right, that's the difference between multiplication and division, or division and multiplication. Okay? So yes, I'm going to be painful and make you write this out. But I will tie it into exponents. So here we go. The decimal, you see this on your paper? The decimal is right here. We call these numbers right here, right? From 1 all the way to 9, we call these the what? We call those the ones place. We call these numbers right here the tens, and yes, you must write this. To go in the other direction, the one that everyone screws up, the first decimal place is not the once place. It's the tenths place. 10 of these makes one of those. 10 of these makes one of those. So it goes from left to right in the decimals. It goes tenths, hundreds, thousands, 10 thousandths, and then continues in that pattern. Right.
I did.
The whole thing.
The whole thing?
Right. We're not done yet.
Where do you put
I said I was going to tie this into exponents. How in the world am I going to tie this into exponents?
Very careful.
What do you think, Genevieve? So exponents are repeated multiplication. We have a base 10 system, so we're repeatedly multiplying by 10. So which one up here, Jace, can you rewrite as 10 to a power? So which one up here can you right now write as 10 to a power? Can you write 100 as 10 to a power? How would you write that?
10 to the 100.
Oh no. That would be a 1 followed by 100 zeros. Yes. So 100 could be written as 10 to the second power. Do you agree? What would 1,000 be written as? 10 to the third. Did anybody see a pattern emerging here? What should I write right here? What should I write right here? 10 to the 0. Now I'm going to catch up and erase my poor handwriting. Okay, so that kind of makes sense. And then we're going to pause. We okay? So we said to go from right to left, we multiply by 10. So if you multiply by that 10, that would be one more than that. We go over here, we multiply by 10 again, so that would be one more than this. If we multiply by 10 and one more than this. So clearly, with your knowledge of numbers, you can kind of figure out that this one should be, what should I write right here?
Divided by 100.
It should be,
110.
well, what is 10 to the 0?
Okay, so
What is 10 to the 0?
Okay, so 0, 1.
What is 10 to the 0?
1.
Who said 0? What is anything to the 0 power? 1, except for 0. So what is 10 to the 0 power? Now stay with me. We said to go from right to left, you multiply by 10. But we said to go from left to right, what are you supposed to do? We said 10 to the 0 is what number? And what am I supposed to do as I go in this direction? Divide by. That's literally why this is called the 1/10th place. There you go. Now, wait a minute. How many 10s do I have written right here? How many 10s do I have written right here? So it really should be 10 to the first. So I'm going to make it nice and neat. There you go. Now, for those of you that really wanted to say, wait a minute, shouldn't that be 10 to the -1? Hold that thought. Hold that thought for another class. Jaden, what's your question?
So isn't there a way to do division in exponent?
There is.
Isn't it like you put, let's
How about we wait for that class? And if you really want to know the answer, I'll tell you at the end of class. But for right now, I don't want to open up that can of worms.
but it makes this a whole lot easier.
Okay. All right. Guess what I should write right here?
1 divided by 10 to the second power.
Okay. So forth and so on. And that is why this is called the 10 squared, or 10 to the second power is 100. That's why this would be 1 over 100, or the 100th place. 10 to the third is 1,000. That's why this is called the 1,000th place. So that's why we don't have a once place. Because 1 divided by 10 is 1 over 10, not 1 over 1. Okay? I know that for some people, they're like, why isn't there a once place? Also, 10 tenths makes 1. Believe it or not, you'll be using all of this today. All of this today. Okay, so that's why we put it in box 1. Okay? Cadence, you didn't have all this copied down. This is in the book as well. All right, here we go. I'm moving on. Yes? Okay. So, new idea. All numbers are decimal numbers. What?
Yeah.
You're saying 42 is a decimal?
Yes.
Why?
Because you have to have, if there's a decimal.
Where's the decimal?
Behind the 2.
Why isn't it written there?
Because it's not necessary.
So what's the decimal number then?
0.
Well, 0 isn't a decimal number, nor is 42. What's the decimal number? If I say decimal number, aren't you expecting something, point something? So what's, oh, 42.0. No, I know what both of you are saying, but I wanted to come out the way that you said at the very end. Yes. So it turns out that all whole numbers are decimal numbers as well. We choose not to write the 0 because we are efficient or lazy, whichever one you want to say. But also remember, I could have put a string of zeros after it, and that's still 42. So that seems kind of strange that you'd have that many zeros, which is why we don't write that. Okay. Another note. 0.37. Typically, you see this with a where? In front of it. Typically, we see it this way. Does anybody know why? Okay, this zero is called a leading zero. And the reason we put that is simply because, so we don't, go ahead. Well, you see this little tiny, tiny, tiny dot? Guess what happens if you're going through things really quickly? You don't even see the dot, and you think it's 37. However, if you see a 0 and then 37, you're like, wait, why is there a 0 there? And then you pay more attention. That is literally the only reason. You do not have to put a leading 0. I would always encourage you to put a leading 0, but the only reason we put a leading 0 is so that I know it's a caution for us to make sure that we realize it's 0.37. Our book will always put a leading 0. You will always see me when I do the math, when I'm adding, subtracting, multiplying, dividing, right? I'll put a leading 0 so you don't mess it up and think it's 37. But when you physically do the math, like calculating, you don't have to have a leading 0. Some people put it in there, but you don't have to have that leading 0. All right, new idea. This is called decimal expansion. Once again, this should have been somewhere around 4th grade. Decimal expansion means this. All of these numbers right here can be written individually. Can be written individually. What in the world am I talking about? Is this really a 3? I'm pointing to the first 3. Is this a 3? Heck no. What is it? It's 3,000. It's not 3. It's 3,000. Is this a 1? It's a 100, and that's a 3. This is what we're doing. We're going to write those numbers, right, as a summation, that means adding, of the individual numbers. So if I wanted to do this, I can't write 3 plus 1 plus 5 plus 3, because this is really, the first 3, 3,000. So that 3 is really 3 times 1,000, yes? Plus 1 times 100. Plus, and you can kind of see where this is going. Okay? We good? Right. You're like, well, where are the decimals? Well, remember, if there were decimals, we could continue that process. Right? So if we added all that up together, we would get to, well, the number we started with. Why are we doing this? It's to teach you place values to make sure you know these things. Okay. Hey, now I got a decimal. Okay? So what is this number really?
16.9.
Okay. In decimal expansion, it is, take the first number on the left, 1 times plus 9 times, right out of the bat, you got it right, times, well, what do you have in box number 1? What place is it in? It's in 0.1, right? So 9 times 0.1 would be 0.9. There is your decimal expansion. Merry Christmas. You have this for homework, right? So you're like, this is kind of painful. So I didn't give you 40 of these to do. I did give you some. Questions? Could you do this right now with any more examples?
No. Yeah.
All right. Some of you are saying yes, some of you are saying no. So let's do another one. All right. Go ahead, Braxton. Tell me what to write. 2 times 100 plus times 1. Now, if you look in the book at their example, they don't write 7 times 1. Guess what they write? They just write plus 7. I kind of like this. The pattern is a bit more, I don't know. It's showing you that the 7 is in the 1's place, the 5 is in the 10's place, the 2 is in the 100's place. Okay? The book just says plus 7. So, well, how come you get to multiply that, but you don't get to multiply this one? And that's kind of my thought process. All right, one more. Here we go. What do you got, Priscilla? It's on your paper. It's on the board. First number on the left. What is it?
4
Times
1
plus. We could say 0 times 0.1, but that's just 0. We can leave that one out.
2
Got it. Keep going. 0.01. Very good. Notice I left off this 0. If you will make a mistake, it won't be on this. It'll be on the next thing we do. I'll show you that when we get to it. Okay. If you have a 0, you don't need to write 0 times 100 or 0 times 0.1 or whatever it is. You can leave that part out. Who's lost? I didn't think anybody would be. All right. Go ahead, Kai. Last one.
What? Yeah,
I literally just said if there's any zeros, you can skip them.
okay, so then 5 times 0.01
Plus
7 times 0.001.
Got it?
Sure.
All right. Easy or hard?
Easy.
Boy, it's painful, right? So let's just do 3 and call it a day on this, right? So do these 3, box 2, write the answer. Do these 3, box 2, write the answer, and we will move on. Anybody need help right off the bat? Good, because I got to take a roll. I forgot to. Who's done? Takes a little bit of time. It's painful. I remember doing this in 7th or 8th grade, like, oh my God, take me away from this. This is, when would I ever do this? And it's just we're just trying to make sure you have your place values solidly in your brain. Solidly in your brain. You didn't do that in 3rd grade.
I did.
All the other ones, yes, you did. Yes, you did. All right, Landon, you got the first, Smalley? You got the first one?
Yeah, it's 3 times 10
Plus.
plus 8 times 1.
All right, there we go. Somebody knew. Somebody knew. Go. Plus. Plus. All right, that was good job. Good job. Good job. Good job. All right, Grayson, you got the last one? Why do they always, teachers always call the person that's about to fall asleep?
I'm not falling asleep.
Okay.
Okay. 4 times 0.01
Plus.
7 times 0.00.
I had to count 0, 0 for you. Very good. Good job. And you were paying attention. I saw. All right, we good with this thing? We can put this one away?
Yeah.
Good. All right. We're not going to do box 3. That's just too much, right? But I did have a box 3 in case, for those that did it, in case we need extra practice. No. So now we're going to switch. Get it?
Yeah.
Oh.
Now I'm going to give you the decimal expansion. You must write the number. Now you're like, well, that's just as it. No, this is the one that will cause you problems. I will put this on the quiz, and this was the one that will cause you problems. Guess why it will cause you problems? Because, well, let's do it. So let's see. 5 times 10 is 50. 4 times 1 is 4. 5 times 0.1 is 0.5, and 7 times 0.01 is 0.07. So if we add all those up, right? Guess what it looks like is going on? Oh, by the way, there's the answer. Guess what it looks like is going on? It looks like all I'm doing is writing this number, this number, this number, this number. Is that what I did?
Pretty much.
Pretty much. And that's what will lead you to a problem, other than the decimal place, right? But you could probably figure that out. Oh, the first one gets a decimal. Guess why this will cause you problems? Who can think this one through? Why is it going to cause you problems? What do you think, Genevieve?
Sometimes
Sometimes there'll be a 0 involved and you skip it. And so it's not just write the numbers exactly the way they appear, right? Other times when there's a 0 involved, so you got to be careful. I'm not saying you literally got to line the numbers up. You just got to be careful. For me, if I was doing it, I would go to the far one on the left and say tens place. Do I have a ones place? Yes. Do I have a tens place? Yes. Do I have a hundreds place? Yes. When you're skipping one, you'll notice immediately, oh, I'm missing a tens place. For instance, the big but here, right? For instance, so be careful. So for instance, I got a hundreds place, yes? The next one should be a tens place. Do I have a tens place? No, so I know I had a 0 where there should be a 10. Do I have a tens place? Is that tens place? You're not even looking at the board, Kai. Do I have a tens place? No. I do have a hundreds and I do have a thousand. So I've got 2 zeros involved, right? For those of you that truly do want to stack the numbers, right? Remember, you got to line decimal places up when you add, right? Well, then you can see what you're missing. I'm missing a tens place and I'm missing a tenths place. So that when you add them together, got zeros involved. I will catch a bunch of people with this on the quiz. Something this easy, you kind of blow it off, and you're like, oh, that's way easy. I'm not even going to pay much attention now. And then you miss one that had some zeros, so be careful. All right, do box 4, please. Do box 4. My recommendation is usually the best. Hey, look, I got hundreds. Do I have a tens? Do I have a ones? Do I have a tenths? Do I have a tenths? Do I have a hundreds? Do I have a thousands? Jaden, what's your question?
I'm gonna answer
You are the oldest in the family, yes?
it. I know I'm the youngest.
You're the youngest?
I have 2 brothers who are in their 20s. I have 5.
Yeah, you've told me that. You've told me that. For some reason, I thought you were the oldest. Then.
Why would I be the oldest?
Why couldn't you be the oldest?
I don't know. What makes me have an older?
Well, then if you were the oldest,
You do like to answer lots of questions.
That's because I ask a lot of questions.
if you was the oldest, you would be in this class.
All right, who's still working? Go ahead. Olivia, you got the first one done? No? Okay. You got the first one done? Go for it. Say it one more time.
62.16.
Well, literally, what's the first one say right there?
I read that.
Okay. See how easy it is to make that mistake? What do you got? 620 point. All right. Now, we are going to do it this class as well, but we got a problem with this. How many people right now, don't say it, you know how to read this? And I'm going to say 0.16 is, well, technically it is a way of reading it, but there's a better way of reading it, which we'll learn here in a second for those you don't. Do you understand what I mean by how do you read this for decimal numbers? Okay, I didn't ask for an answer yet.
I'm trying to get to the other question.
I know. Olivia, you got this one? No? Olivia, help me out. What's this place right here? Is that the tens place, the ones place, or the tenths place? Tenths. So I need a point what? I need a 0.8, followed by a, is this the hundreds place? Okay. How do you know it's not the hundreds place? You're going to take box 1 and see where you wrote hundredths, whether or not it has a 0.01. Hey, it's got a 0.01. It is the hundredths place. Is this the thousands place? Yes or no? Okay. You're going to take box 1. Do you see where it says thousandths? It says 0.001. Does that say 0.001? It does. I mean, that's how you're going to use this tonight. So we get, oh, we need a leading 0 because we don't have a ones place. So we get 0 point, help me out.
830.
Oh, somebody knows how to read decimal numbers. All right, hallelujah. All right, for those of you that don't, we're going to learn that today, or we're going to refresh your memories. You should know how to read that. All right, do we need to do box 5?
Yes.
All right, I'm skipping it. For those of you that did it, boy, that's a lot of zeros,
Yeah.
right? I'll put something like maybe the first one on the quiz. Second one just has a lot of zeros. This is my Jaden question right here. Did you get it right, Jaden? Okay. All right.
Good job, Jaden.
We need to move on to the last one because in my eyes, some of you still don't know how to do this. And that is, how do you read decimal numbers? So words that describe decimal numbers. Well, tens doesn't describe a decimal number, right? We go tens, ones, and then we get to the ones that add in THS, right? Tenths, hundreds, thousands, 10,000s, 100,000, millions. They all end in THS. Can you confuse these two if you're not paying attention? Absolutely, if you're doing it really fast, right? But all the decimal numbers end in THS or DTHS, right? All right. Now, I'm going to give you words, and you have to write the decimal numbers. It says 7 and 4300ths. First and foremost, there's a decimal up there. Which word is the decimal? You see the word and, that's the decimal. You see the word and, that's the decimal. So I'm going to look to the left of the word and. What do I see? If it's 700, it'll literally say 700. It doesn't. It says 7. So that's 7 points. All right, 4300ths. Here is the rule. The rule says this. The rule says this word right here, hundredths, its place value is based upon that number right there, the 3. The 3 is what determines where the word hundredths goes, right? So how do you figure this out? Well, you see the word hundredths? What's the last digit? 3 has to be in the hundredths place, and anything to the left of the 3 takes up each specific, I did it in the wrong order, each specific value. The 3 goes in the hundredths place, and then any number before the 3, in this case the 4, gets the next place value to the left. This is hard. Most kids will mess this up. So let's do a few. The 3 is in the hundredths place, and then the very preceding digit, the 4, takes, in this case, the tenths place. Sounds pretty easy, right? Until you get to the more complicated one. It says 19 and 14 thousandths. Where's the decimal place? Where's the decimal place? And is your decimal place. Anything to the left goes to the left of the decimal place. That's easy. That's 19, right? Decimal place. Hey, which number, 1 or 4, gets the thousandths place? It's always the last digit, the 4. The 4 gets the thousandths place. The 1 gets the one right before it. And well, wait a minute, it goes thousandths, hundredths, we're missing a tenth. That's why it gets a 0. This is hard. Yes? Okay, we better do some more. 7 and 300ths. Where's the decimal? And is your decimal. Anything to the left of and, right, goes to the left of the decimal. Those are going to be, it's going to say 753 and, you won't make a mistake on that. It's what's to the right that you make your mistake on. Hey, hundredths place. What digit goes in the hundredths place? Well, there's only one number, 3. So the 3 goes in the hundredths place, and well, you're left with zeros for everything else. So what's the final answer? 7.03. Jaden? All right. Here we go. Where's the decimal place? And what's to the left? So 19 points. All right. What is the last digit here? 8 goes in the thousandths place. If you need to literally line up box number 1 with those values, you can figure out what gets zeros and what don't get zeros. This says 8 gets the thousandths place, 4 gets the hundredths place, and 1 gets the tenth place. So there's no zeros other than the leading zero. But when you add these two together, you get, that one is the, I won't have a kid miss this one. But as soon as there's some zeros involved, oh yes, people will miss it. So the steps are, see the word, the first digit or the last digit, however you want to think about it, the last digit to the right gets that place value. And every number before it, or the decimals, takes up each individual place as we move to the left. Box 6, let's do this together. Here we go. 4 and 1500ths. So 4 points. What number goes in the hundredths place? What number goes in the tenth place? Okay, so there's no zeros. So 4.15 or 4 and 1500ths. 104 thousandths? Well, clearly that's 100 points. What number goes in the thousandths place? So as long as you keep box 1 in your mind, maybe you want to put it on a resource card, maybe you don't. It's up to you, right? But make sure you put enough zeros so that the 4 winds up in the thousandths. Remember, it goes tenths, hundredths, thousandths. If there's a mistake to make, it's always in the decimals. It's always, that's a lot of zeros. 2 more. 19 and 5 thousandths. And is your decimal. 19 goes in front. 5,000 is only one number, and it goes in the thousandths place. So that's C. Tenths, hundredths, thousandths. So 0.005. Put those together. 19.005. What? There's no and. Okay, well, let's see. So if there's no and, that means the whole darn thing is a decimal number. We're still going to go to the last digit, or first, however you want to think about it. Farthest digit to the right, it's an 8. The 8 is in the 10,000ths place. That means the 4 is in the...
10,000 place.
No, the 8 is in the 10,000. The 4 is in the thousandths. That means there's no hundredths and there's no tens. So that means 2 zeros with a leading zero. So 0.0048. How many people beat me to that?
My bad. Oh, man.
Good. Because that's it.
Oh, drop.
All right. Any question on anything we did? Of the three things, which one was the hardest one? Some are going to say none of it, right? Others are going to say, I don't know, this one is the one you can make a mistake in pretty easy. This one as well, if there are a bunch of zeros. All right, if you have any specific questions, ask me during student advisement. Cadence, thanks for showing up for class. If you have any questions, send me an email. You are now caught up. I will post this video, that's for everyone, on Teams. I'll have this posted by tonight. I'm usually pretty good. I get it done usually before 7 o'clock, but there might be a day or two that I don't. I wonder why I did both